Lesson 10.5, Analyzing the Slopes of Polygons. Our essential question is, how does the slope help you to classify a quadrilateral? We have quite a few new vocabulary words today. The first one is quadrilateral. A quadrilateral is a polygon with four sides. The next five vocabulary words are examples of quadrilaterals. So a trapezoid is a quadrilateral. So that means that it has four sides. And one of the characteristics of a trapezoid is that it has one pair of parallel sides. So a quadrilateral with one pair of parallel sides. So a trapezoid looks something like this, where there's one pair of sides that are parallel. A parallelogram is also a quadrilateral. I'm going to abbreviate quadrilateral now. And a parallelogram has two pairs of parallel sides. So a quadrilateral with two pairs of parallel sides. So it's a little bit more specific than a trapezoid. Instead of having one pair that's parallel, it has two. So a parallelogram looks like this. You can think of it as like a slanted rectangle. The next vocab word is a rectangle. Well, a rectangle is a quadrilateral with four right angles. You could also think of it as a parallelogram with four right angles, because it does have opposite sides that are parallel. I could draw the arrows for the parallel on the parallelogram, like this, where it's got two pair of opposite sides that are parallel, and then on the rectangle, with its four right angles have little boxes in them, like that. A rhombus, the next new vocab word is a rhombus. A rhombus is a quadrilateral with four congruent sides. So now we're switching from talking about sides being parallel to sides being congruent. So four congruent sides means that it kind of looks like a parallelogram sometimes, only the sides are all the same length. So it looks similar to a parallelogram, but the sides are like the sides on a square. You might think of it as a diamond shape also. And then my last one is a square, and a square has four right angles and four congruent sides. So it's got the four congruent sides, but it also has the little squares for the right angles. My drawing is getting a little bit too small. So, quadrilateral with four congruent sides and four right angles. Okay. So, we are going to be working in this section with all of these different types of quadrilaterals, maybe trapezoid, parallelogram, rectangle, rhombus, or square. 5 different kinds of quadrilaterals. And we are going to be using the slope and the distance formula to help us classify quadrilaterals. So the slope and the distance formula. The slope can help us figure out if sides are parallel, because we learned back in chapter 4 that when slopes are the same, they represent parallel lines. Parallel slopes stay the same. We also learned that perpendicular slopes flip and change, so they're opposite signs and reciprocals. Perpendicular slopes can help us figure out if something is a rectangle or a square, because perpendicular means that they intersect at a right angle. So the idea of slope can help us with the trapezoid, the parallelogram, because we're looking for parallel sides. Can also help us with the rectangle and the square, because we're looking for perpendicular for those corners. And then a rhombus, the distance formula can help us with a rhombus and a square, because sides have to be the same length. So we're using a lot of concepts to help us classify our quadrilaterals in this section. Okay, this next problem says the graphs of y equals 1/2 x plus 1, y equals 1/2 x minus 3, and y equals negative 3x in the coordinate plane contain three sides of a parallelogram. Give an equation for the fourth side. All right, so I'm going to graph the sides that we know. So the first one says y equals 1/2 x plus 1. So I start at 1 on my y-axis because that's my intercept. So remember, y equals mx plus b, where b is the y-intercept and m is the slope. My slope is 1/2, so I rise 1, run 2. So up 1 over 2 to the right for my first line. I can reverse it and draw my line. Like that. My second line is y equals 1/2 x minus 3. So that one starts at an intercept of negative 3. The slope is still 1/2 though. So this should be making sense. We're looking for a parallelogram. So these two sides right now are parallel to each other. Then, so those are going to be opposite sides. They're parallel. Then I've got my third side right here. Y equals negative 3x. So this one has an intercept of 0. And the slope is negative 3, so it goes down 3 over 1. So this is a very steep line. Going downhill. So for my fourth side of my parallelogram, I am going to need to have another line that is parallel to the one that I just drew in red, because opposite sides are parallel. You have to have two pairs of parallel sides. So in order to keep it parallel to that red line, which was y equals negative 3x, I need my new line to have that same slope, but a different intercept. So I am just going to choose a new intercept here. So I'm going to go up, let's say 4, right here, and then use my slope down 3 over 1, down 3 over 1, and draw my line. So my new equation is y equals negative 3x plus 4, and I formed a parallelogram right here by the intersection of my lines. My opposite sides are parallel. So there's my parallelogram. So the fourth side, the key here would be that there's an infinite number of equations you could write. You just have to keep the slope the same as that third line, because the first two were already parallel. So we just keep the slope the same. We pick any intercept we want right here, and we're good. We've got a parallelogram. The next problem says, the coordinates of three vertices of quadrilateral of A, B, C, D are A, negative 3, 1. B, 2, 1. And C, 6, negative 2. For which coordinates of D will the quadrilateral be a rhombus? All right, this is a trickier problem right here because a rhombus has 4 congruent sides. So that means that we have to make sure that they are the same distance away from each other. So we're going to need the distance formula. The distance formula you can use looks like this, big square root, or you could use the Pythagorean theorem instead, and the Pythagorean theorem is a squared plus b squared equals c squared. That's if you want to turn it into a right triangle, where you have a, b, and c. So I'm going to look at where these points are located on the coordinate plane, and then we'll decide which one we want to use to find our distances, okay? So A is negative 3, 1. So here's A, negative 3, 1. B is 2, 1. C is 6, negative 2. All right. Now I have to connect them in the order of the letters here because it said over here quadrilateral A, B, C, D. So that tells you the order that you connect them to each other. So here are my first 3 sides. I need one more side so that it's a rhombus. It's a rhombus. Okay, so I can count this side from A to B. If I count it as I move, 1, 2, 3, 4, 5. This side is 5 units long. Now, I should make sure that BC is 5 units long. So if I use the distance formula for this, the distance formula, I'm going to label these coordinates x1, y1, and x2, y2. And I'm going to plug it in the distance formula. So I'm finding the distance from B to C. So x2 minus x1, 6 minus 2, quantity squared, plus y2 is negative 2 minus 1, quantity squared. 6 minus 2 is 4, so 4 squared, plus negative 2 minus 1 is negative 3 squared, 4 squared is 16, negative 3 squared is 9, 16 plus 9 is 25, so the square root of 25 is 5. This side is also 5. So what that tells me is my other 2 sides also have to be 5. So I need to pick a location for that 4th point. So I'm going to use green for this one. I'm going to pick a location for that 4th point so that the distance is 5. So if you notice where point C is, if I go straight across 1, 2, 3, 4, 5, I think this is where my last point should be. I've just counted this side to be 5. So this ordered pair that I've got is 1, negative 2. So I believe D is 1, negative 2. So what I'm going to do is I am going to calculate this side right here using the distance formula again, just to make sure that I've got it in the correct spot. So this distance would be AD or DA. So now my distance formula, I am going to use x1, y1 here, and x2, y2 here. Okay, so a little bit of a lopsided square root. All right, x2 minus x1. 1 minus negative 3 squared plus y2 minus y1, negative 2 minus 1 squared. 1 minus negative 3, that's a chunky plus. So 1 plus 3 is 4. 4 squared plus negative 2 minus 1 is negative 3, so negative 3 squared. 4 squared is 16. Negative 3 squared is 9. Square root of 25 equals 5. So I have found my fourth point. Point B is 1, negative 2. Final answer. Our last example says the coordinate, a square is drawn on the coordinate plane. One side of the square is on the line 3x plus 4y equals 12. Which of these equations could be another side of the square? All right, so we are talking about a square here. And the characteristics of a square are that there would be 4 right angles and 4 congruent sides. So 3x plus 4y equals 12. So the first thing I better figure out is where that line is. So I need to write this equation in slope-intercept form. So if I subtract 3x on both sides, I get 4y equals negative 3x plus 12. Then if I divide everything by 4, I get y equals negative 3/4 x plus 3. So if I go up 3 for my intercept, then use my slope, negative 3/4 is down 3 over 4. Right here, or up 3, back 4. So this is one side of my square. All right, now I need to look at my answer choices to see which of the other equations could be another side of the square. Well, remember, to be a square, you have to have 4 right angles and 4 congruent sides. So if I look at B, for example, so I'm going to check this one first. Y equals 3x minus 2. So negative 2, and then go up 3 over 1, up 3 over 1. My question would be, did that create a right angle? No, that didn't create a right angle. To create a right angle, so I'm going to get rid of that line. To create a right angle, I would have to have another side that had a slope that was the opposite reciprocal. Remember, right angles mean perpendicular. So right angle means perpendicular because a right angle is a 90-degree angle. So if my sides are perpendicular, the slope would have to flip and change. So this, negative 3/4, if you flip it and change the sign, negative 3/4 perpendicular to that would be positive 4/3. So this slope was 3, so it's definitely not this one. So I can cross this one out. The next one, let's see, which other one do I want to try? I guess I could try the first one, 4x plus 3y equals 24. So I'd subtract 4x, 3y equals negative 4x plus 24. And then I divide everything by 3. So y equals negative 4/3 x plus 8. All right, I better shrink that. Oops. Shrink it and move it down here. Okay, negative 4/3 x plus 8. So 3, 6, so 8 is up here. If I go down 4 over 3, down 4 over 3, this definitely does not look right. That is not parallel. and it's not perpendicular, so that is definitely not going to help me create a square. So I'm going to get rid of that one. Okay, so it's definitely not that one. Now we're down to 2. So this can go. Now we've got negative 3/4 x plus 7. Well, negative 3/4 x plus 7, so 7 is up here, down 3/4 here. So this one is parallel. This one is parallel. If it's parallel, I could create a square this way. Create a square. I know I just estimated that, but I think you get the idea. So opposite sides of a square are parallel. And then adjacent sides, the ones that are next to each other, are perpendicular. So this one is looking really good to me. So that could definitely be another side of the square. So that one I'm going to keep. Now I'm going to check the bottom one, because it says which of these equations could be another side of the square. There could be more than one answer here that works. So I'm going to check the last one and see how the last one looks. So 3x minus 4y equals negative 12. If I subtract 3x, negative 4y equals negative 3x minus 12. Divide by negative 4. So y equals, a negative divided by a negative is a positive. So positive 3/4 x plus 3. So my slope on this one is positive 3/4 x. So it didn't give me what I was looking for over here, which was a positive 4/3. So my slope isn't perpendicular, and it also isn't the same, so it isn't parallel. So that one's not going to work either. So I've checked all of them, and the correct answer is letter C. We are done with our lesson for today, so you should be able to write a summary now answering your essential questions.